Hello, my name is Shreya Kantamsetti, and today I will talk about parasites and allergy-inducing proteins from shellfish. In the last 2 decades, allergies have been a growing problem in the modern world, and as we keep discovering new foods. Of the big 8 food groups causing allergy, shellfish are one of the more prevalent allergens. Presently, 10.3% of the world population suffers from shellfish allergy, with higher rates in countries that thrive on seafood, showing that this allergy has a massive impact on public health. Of this 10.3%, 30,000 people have emergency room visits, and about 150 to 200 people die from severe reactions like anaphylaxis, oral allergy syndrome, and asthma attacks. In order to combat these reactions, there are a few solutions. You can use oral antihistamines, which are pills that reduce the allergic reactions, or nasal spray, which is liquid medicine that you spray into your nose, which relieves congestion, or even immunotherapy. These include allergy shots or tablets and are the only ones that actually change the immune system in order to fight off the allergies. The problem with these solutions is that they are only temporary or take many years to become permanent and may not even fully remove the allergic reactions. For this reason, there needs to be a cure to prevent the allergic reaction from even happening. On shellfish, particularly crustaceans and mollusks, there are 6 proteins that cause allergic reactions, the 2 most common being tropomyosin and arginine kinase. According to previous research done by Dr. Joseph Igeti, there are certain parasites that can cross-react with these proteins and essentially remove them from being susceptible to a particular food, in this case, shellfish. In return, the allergic reaction would never occur. According to researcher Adi Brahman from the Econ School of Medicine, most people in developing countries have increased exposure to pathogens as they deal with common parasitic infections on a day-to-day basis, which has resulted in rural populations having regulatory cells that help reduce allergies. This fact shows that there is a relationship between parasites and allergies, as people in the developing countries may not have allergies because they already have a form of parasite inside their body to fight off or block off the allergy-inducing proteins. For this reason, it is crucial that we look at parasites. They're the key to preventing allergies. So this now brings me to my research question. Which parasite has proteins that best match the allergy-inducing proteins from shellfish? For my method, my first step was to choose a list of parasites in shellfish. The 4 most common parasites were chosen, and the shellfish only contained of crustaceans and mollusks for the purpose of this research. My second step was to find the protein sequence for each species and protein and do the blast search. For each species and protein, a sequence search had to be made in order to use it inside the blast search tool. Once that was found, the sequence matches were found through the blast tool. And my third step was to analyze all my information. All the information from the blast tool, such as the number of matches between both sequences, was analyzed and compared. Here are the list of materials that I have used. 4 different parasites, 4 crustaceans, 2 mollusks, and 4 different proteins were used. These are the results, and the results displayed here will only contain the most statistically significant parasite for each species, so they are not the full results. From them, it is easy to interpret that the tropomyosin protein appears the most, showing that this protein has the most cross-reactive activity with most of the parasites. The Ancylostoma duodenale parasite appears 3 times and is usually paired with the arginine kinase protein, but once with the myosin light chain 1 protein. The Acerus lumbricoides has 4 appearances and is always paired with the tropomyosin protein. Based on the number of appearances of each parasite, Acerus lumbricoides and Ancylostoma duodenale are the best parasites to target these 2 proteins, as Acerus lumbricoides always targets tropomyosin and Ancylostoma duodenale usually targets arginine kinase at least 66% of the time. Moreover, the tropomyosin protein has been identified on over 60% of shellfish And arginine kinase has been identified on over 6 crustaceans and 1 mollusk species, which is why it is important that these parasites, the Ancylostoma duodenale and Acerus lumbricoides, target these 2 proteins the most. The 2 parasites had max scores of over 350 and query scores of 98%. Max scores being there are 350 parts of the sequence that match, and query scores being that at least 98% or more was found to be matched of both sequences. And this only occurred when the 2 parasites were combined with tropomyosin or arginine kinase, conveying that these parasites are the best to use in order to remove allergic reactions. For future research, now that we've found our 2 parasites, Acerus lumbricoides and Ancylostoma duodenale, we need to find what these parasites do as soon as they enter the human body and the specific method or technique they use to ideally turn off the allergy-causing proteins. After this, scientists can find a way to chemically do what parasites do to attack allergy-inducing proteins, so that the parasites are not being directly injected into the human body. These chemicals can then potentially be turned into a vaccine a person could take in order to minimize or block their allergic reactions caused by shellfish. And that's the end of my presentation, and thank you so much for listening.